Hey there, awesome physics students. I wanted to do an example of drawing motion graphs, starting with a velocity time graph, and then how would you take that graph and get the corresponding acceleration time graph and the corresponding position time graph. Okay, so I've already drawn one here. We can imagine this one is for a runner. It's nice to have a story to go along with these, and so imagine this one is for a runner. They begin at their house from rest, and they run, they define north to be positive, and they run north and speeding up until they reach 6 meters per second. 6 meters per second is about 12, 13 miles an hour. And they run at a constant speed north for 5 seconds, and then they begin to slow down, and then they stop. And then they turn around and run the other direction. So they begin speeding up in the negative direction, and they run for 2 seconds, speeding up to negative 6 meters per second. So this means that they're now traveling 6 meters per second south. Okay. So then how do we obtain from this the acceleration time graph and the velocity time, the position time graph? Well, I think if we're doing this, I think taking the slope of things and creating a graph from that is a bit easier. And because the acceleration time graph is the value of the acceleration time graph is the slope of the velocity time graph, I think we can start on that one a little bit easier. So let's do that. So here's the acceleration time axis. So what we need to do is, when you're doing this exercise, remind yourself, and it seems silly, but just say it out loud. The slope here is the value here. The slope here is positive and constant, so the value here must be positive and constant. So a constant positive value for acceleration for the first 3 seconds is right there. Okay, and while you're doing this, it's important, I recommend, to get the shape correct and then fill in the values after you've gotten the shape correct. All right. Again, the slope here is the value here. The slope here is 0 from 3 to 8 seconds. So the value here is going to be 0 during those, that takes us up to about 8 seconds. Okay. And then again here, the slope here is the value here. And the slope here is negative and constant. So the value here is going to be negative and constant. And so the value is going to be like that. Okay. Now, how do I get the actual values for these? Well, I need to take the slope. So the rise of this is going to be positive 6, and that occurs over 3 seconds. So positive 6 meters per second over 3 seconds equals 2 meters per second per second. And that's the acceleration, the value of the acceleration for the first 3 seconds. Of course, here it's 0. That one's easy. And then this one, it decreases by 12. So that's a negative 12 meters per second change in velocity over, this goes from 8 to 12 seconds, and that occurs over 4 seconds total. So 12 divided by 4 is 3, and that's a negative 3 meters per second per second. So each second we add negative 3 meters per second to the velocity. Okay. So yes, so this graph is nice and done. We've gotten all the values filled in there. Now let's do the harder one, which is the position time graph. So I'm going to say, for this one, of course, you need to know where to start. This velocity time graph doesn't tell me where to start. The problem has to tell me that. So we're going to say that he starts at x equals 0 when t equals 0. Okay? And that's going to help us get started there. All right. So we begin here, and then again, you want to repeat slope and value. So the slope here is the value here. I don't have anything drawn here, so the value here begins at 0, so that means my slope here needs to begin at 0. And a 0 slope is flat like this, so I draw that flat like that. And then the value here is increasing in the positive direction. So my slope here needs to increase in the positive direction. Hope you can see what I'm doing. By repeating this out loud, I'm reinforcing and helping prevent myself from getting confused. So a increasing positive slope looks like that. And that's for the first 3 seconds. So it's getting steeper. And then the value here is constant and positive. So my slope here needs to be positive and constant. Constant slope is a straight line. So I need to make the slope here like that. It keeps going like that until about 8 seconds. Okay, so that's a straight line there, segment. And then I need to take this, look at this part here, and remember that the value here, and I'll just concentrate on this upper positive section here. The value here is the slope here. Well, the value here is positive, but it's getting less. It's going towards 0. In fact, certain points may be useful, like the point here at 0 and the point here at 0. Those are, you can think of those as anchor points. I know the slope there has to be 0. That's flat. So I need to somehow get to a flat slope here. Since the value is decreasing, the slope here needs to decrease, and a decreasing slope is getting less steep. So I need to go like that. Okay, and that is up at this top point, that is flat. It's a 0 slope. That corresponds with right there, 10 seconds. Okay. Now finally, at this last segment here, the value is negative and becoming more negative. So my slope here needs to become negative, which means that way, and it becomes more negative, which means it gets steeper in the negative sense. Okay? So this is 0 slope, and then my slope goes back down like that. Okay? Okay, and the nice thing about this is that I can go back and check this. Okay, so here the slope is 0, value is 0. Slope is positive and increasing. It's getting steeper. Value is positive and increasing. Here the slope is positive and constant. Value is positive and constant. Here the slope is positive but decreasing and 0 to 0. Here the value is positive but decreases to 0. Here the slope is negative and getting more negative, more steep. Here the value starts at 0 and becomes more negative. Okay, so all of this makes sense. So now I'm ready to fill in the values here. So since I needed this to know this, I can build on that and I can figure out, okay, where is it at 3 seconds? Where is it at 8 seconds? Where is it at 10 seconds? And then where is it again at 12 seconds? At the very end. Okay, so to do that, I can just find the areas here. So I'm going to break this shape up into several different triangles. The area here is going to be, this is a triangle shape. The formula for an area of a triangle is half base times height. So that's going to be half. Base is 3 seconds, and the height is 6 meters per second. Okay, and notice when I keep all my units, the units also cancel out here. So the seconds cancels the seconds, and I'm left with just meters. So a half times 3 times 6 gives us 9. Okay, and that's the units for that are meters, which are the correct thing that we want. So the value there is 9 meters. And then this is just a rectangle. So the area of that rectangle is, it's 6 by the time interval here is 5. It goes from 3 to 8, so that's delta t of 5. 5 times 6 is 30. So does that mean I go to 30 here? No. Remember, the area increments here are displacements. So that tells me how much my position will increase. So I need to increase by 30. So if I go from here to here, this increase has been 30, so that takes me to 39. Okay? And then let me just find the area here. So this is 30 meters. And this part here, the base is 2 seconds. Half times 2 seconds times the height is 6. meters per second. And so half times 2 times 6, that's going to be 6 meters. So I add 6 more meters to this, and that takes me to 45 meters. Okay. Remember, each of these is a displacement, and so I still have to add that to my actual position to get the total position. All right. And then this one is, interestingly, negative area. And so the area for that is, it's again a triangle, half base times height. The base here is 2 seconds, and the height is -6. 2 seconds times -6 meters per second. And so half times 2 times -6 is going to give us -6. And so that means I'm going down by 6. So this is ending at 39 meters. Okay, which is no surprise because it should be symmetric the same way this is symmetric about that. Okay, so this is how you go about starting with a velocity time graph and then getting the other two corresponding graphs. Okay, first, remind yourself of the connection between those. The slope here is the value here, and then keep repeating that. Second thing is, get the shape first, then fill in the numbers last. Okay, hopefully this was helpful.